We're going to go ahead and look at number 13 from the test review. It says, for each problem, find the area under the curve over the given interval. Set up your solution using the limit as n goes to infinity of the lower sum. You may use the graph provided to sketch the curve. You will need to look up the formula. Well, I actually put the formula over here, so you don't need to look that up. So let's go ahead and get started. So we have the function f of x equals x cubed plus 6 on the interval 0 to 2. So let's go ahead and sketch that graph. We know it's an x cubed function, so it's going to look something like this. But let's go ahead and get some good values in here. So if you put in 0, well, it's going to be this function moved up 6. So there we know it will go through 7. And then if you plug 2 into here, 2 cubed is 8 plus 6 is 14. And so the graph looks something like this. And we want to section off the interval from 0 to 2. So we want this interval here. And we want to use the lower sum that I highlighted up here. So the lower sum ends up also, in this case, being the left sum. So we're going to have these little, I'm going to go ahead and draw on a couple representative rectangles here. So there's the first two. And then I'm going to try to sketch in the last one here. That's going to be our last one. So what we want here is we want the lower sum. And remember what we do, we have a bunch of rectangles, so we're going to do base times height. But the base is always the same. So remember, we put the base out front here. And we learned that the base was b minus a over the number of rectangles. Well, b minus a, b is 2, and a is our 0. So this is 2 minus 0. We want n rectangles, so over n. That is our base. And we're going to multiply that by each of our heights. Well, the height is what you get when you plug in the value. So our first value we plug in is just 0. So we're going to put it into our function, 0 cubed plus 6. So actually we'll just write f of 0. Our next one, we're going to move over one base. So here's our base, we're going to move over one base. So that's f of 2 over n. And then for our next one, try to zoom in here a little bit, we have to move over two bases. So that was 2 over n, move over another 2 over n. So I'm going to write this as we're going to do f of, and we want to move over two bases, so 2 times 2 over n. And then our next one, we're going to move over 3 bases, so 3 times 2 over n. And then we're going to go over n minus 1 2 over n's, because we're not going, we have to go all the way up to this spot. We don't go all the way to n, we go over to n minus 1. So we're going to go f of n minus 1 times 2 over n. All right, so now we're going to plug in those values. We'll try to go below the sum here. So this is going to be our sum is 2 over n, and we're going to plug into our function. Our function is right here, so we're just going to plug those values in to x cubed plus 6. So f of 0. F of 0 is going to be 0 cubed plus 6. And then f of n, or 2 over n, is going to be 2 over n cubed plus 6. And then we're going to go over 2 over n's. So that's going to be 2 times 2 over n cubed plus 6. And we're going to go over 3. So this is going to be 3 times 2 over n cubed plus 6. And then we're going to go to our last term here, the n minus 1. So we'll go n minus 1 times 2 over n cubed plus 6. So there is the sum. We can work out a few things here. What we're going to do here now is I'm going to group all these 6's together. So how many 6's were there? Well, there's going to be n 6's because we have n rectangles. So this is going to be 6n, n being the number of rectangles, and we have n 6's. So we have that, and then we have all these cubes. And so I'm going to write all of these out here. We have 8 over n cubed. And we have, looking at this one, we have 4 times, sorry, not 4, 2 cubed is 8. So we have 8, and then times the 2 over n cubed is 8 over n cubed. And then we have 3 cubed is 27 times 2 cubed is 8 over n cubed. And then we have our last one. We have n minus 1 cubed times 8 over n cubed. Now what we're going to do here, we haven't really done before, but I'm going to distribute this 2 over n, but I'm going to distribute it kind of strangely. We're going to distribute it to this, and then we're going to distribute it to this whole thing here. And so it's kind of going to be, and I'll put them in here, like we're having parentheses here. We're going to group all these together. And this gets distributed to the 6n, and then gets distributed to this set of parentheses. So let's do that. When it gets distributed to the 6n, that's going to be 12 n over n. Well, the n's will cancel, so that's 12. And then we're going to distribute it here, and that is 2 over n. And I'll write this all out, but we're going to factor here soon. You might not need to write this step, but I will anyway. Because what we're going to see here is that there's an 8 over n cubed in each one of these terms. And so we still have our 12, we have our 2 over n, and then we're going to factor out an 8 over n cubed, because there's one of those in each term, and we end up with 1. From here, we got a 1 plus 8 plus 27 plus n minus 1 cubed. So this is 12 plus 16 over n to the 4th plus 1 plus 8 plus 27 plus n minus 1 cubed. And we're going to notice what's in these parentheses that I'm highlighting is the sum of the first n cubes. And so we can use our formula up here. Now this formula, hopefully we don't get confused by this. In fact, what I'll do is I'll write this a little bit differently. I'm going to write this, our formula with k's in here. And what we'll do is we will put our n minus 1 in for the k's. So when we put n minus 1, because we're going to n minus 1, when we put that in for the k's up there, it's going to be n minus 1. So we're putting a n minus 1 in for k, so n minus 1 squared, times, we're going to put an n minus 1 in here, so that's n minus 1 plus 1, squared all over 4. So we have 12 plus 16 over n to the 4th times this sum. This is n minus 1 squared plus, really this is just n squared, all over 4, not plus n squared, times n squared. Now what we want to do is we want to let our number of rectangles approach infinity, so our area is going to be the limit as n approaches infinity of 12 plus 16 over n to the 4th times we could think through it, but I'll go ahead and multiply this out. This is n squared minus 2n plus 1 times n squared all over 4. And we'll write this one more time. And if you have a good idea of your multiplying out and limits, you don't have to multiply all this out, but we will. So now I'm going to distribute this n squared to each term. So this is n to the 4th minus 2n squared plus, 2n cubed plus n squared all over 4. And now we want to apply the limit. So we can apply this limit to this sum here. Well, the limit as n approaches infinity of 12, well, 12 is just 12. Doesn't matter what n is equal to, so that's 12. But then we're going to apply the limit also to the other part of this sum. And when you apply it here, we have a 16, and then as n approaches infinity, in this numerator up here, remember the one that's most significant is the highest degree as n approaches infinity. The other two are insignificant. So the ones that I'm crossing out here become insignificant compared to n to the 4th as n approaches infinity. So really what we have here is n to the 4th reduces with n to the 4th, and we have 16 over 4. And so our area is 12 plus 16 over 4. Well, 12 plus 16 over 4 is 4. So 12 plus 4 is 16 units squared. And there you have it. We use lower rectangles, and we let the number of rectangles approach infinity, and we got that the area from 0 to 2 under the function f of x equals x cubed plus 6 is 16 units squared.